All right, so good day everyone. This is another example of how to prove if an ordered pair is a solution to a system of linear inequalities, okay? So what we are given is y is greater than 3x. That's our first inequality. The second one is y is less than or equal to negative x minus 2. And then the third inequality says that y is greater than or equal to 2x. So what we're going to do is substitute in a negative 2, negative 1 for A, and then 0, 4 for B. Now those are our ordered pairs. And we need to prove if we plug in either of those two ordered pairs into the equation, if it would give us a true inequality statement. So what I want you to do for this example, since this is, I got hiccups. Since this is our second example, pause me and try it out on your own. See if you can come up with which one, if any of them, is our solution to our system of linear inequalities, okay? So the very first thing I want to do, set everything up by substituting in a negative 2, negative 1. Give me just a second, I'll be right back. So here's what I did. I substituted in all of my points, well, negative 2, negative 1 into all three inequalities, okay? So now I want to see which one of those will give me a true statement. So here we go. Over here, I know I need to multiply 3 times a negative 2. That's a negative 6. So is negative 1 greater than a negative 6? Now, if you need to see it done again, that's okay. I'll put things on a number line because sometimes that's a little bit easier once you can see things done. Okay, so here we go. Negative 1 is to the right of negative 6. You know as numbers get greater going to the right. So negative 1 in this case is greater than a negative 6. So this is true. We have ourselves a true inequality statement. Now we move on to inequality 2. Y is less than or equal to negative x minus 2. Well, here we have a negative times a negative 2. Don't let that bother you. Negative times a negative looks like a sleeping person. When you're sleeping, ain't you happy? 2 minus 2. Okay? If that don't work for you, I do have another way to determine if what signs are. If you have multiplying, because that's really a negative 1 times a negative 2. I'm going to just go ahead on and write it up here. So what I used to do in the past, and you may have seen this before, it looks like a tic-tac-toe. Always on a diagonal you have positives and everything else is negative. You can read this chart going left to right, horizontally or vertically, up and down. So what happened here, we had a negative times a negative. Negative times a negative is a positive. Negative times a negative is a positive. So that's where we get our 2 from. If you need that to help you remember it, then fine, use it as much as you need to. This works anytime you are multiplying or dividing integers, okay? So here we did the negative times a negative and we got a positive. So now the next thing that we need to do is subtract. 2 minus 2 is 0. We need to know if negative 1 is less than or equal to 0. Well, we know it's not equal to it, but if you look right here, 0 is to the right of negative 1. So for that reason, negative 1 is less than 0. Okay, so this happens to be true as well. So now we move on over to the third inequality. I substituted in my negative 1 and my negative 2 and for y and x. So the first thing I need to do is multiply. I have a positive times a negative, so this is going to give me a negative 4 plus 3. So negative 1, I need to see if that's greater than or equal to negative 4 plus 3. Well, negative 4 plus 3, that adding and subtracting integers on, same sign, add and keep, different sign, subtract. Keep the sign of the higher number, and it will be exact or correct. So anyway, negative 4 plus 3 is a negative 1. So we have a negative 1 and we need to see if that's greater than or equal to negative 1. And in this case, it happens to be true. So what I can conclude, since negative 2, negative 1 worked for every inequality in my system, I can say that negative 2, negative 1 is a solution. Now, if I want to drag it out, I'll say it is a solution to my system of linear inequalities. But to keep the video brief, that's all I'm writing. Okay, so now I'm going to set up the second point, which is 0, 4, and see if that's a solution to our system of inequalities. Okay, so what I did was I substituted in 0, 4 into all three of the inequalities that's given, and I want to see if I get a true inequality statement. So if you feel like you got this, I want you to pause me and then go ahead and try it on your own. Okay, but if you feel like you need a little bit more help, I'm here for you. I'm going to do this one with you. Okay, so if you got it on your own, pause me, go ahead, do it, come back for the answer. If you don't got it on your own, watch me and get the answer so you can do it on your own. Okay, so we want to know if 4 is greater than or equal to 3 times 0. 3 times 0 is 0. Is 4 greater than 0? Yes, it is. I'd rather have $4 than no dollars. All right, so that one is true. Then over here, you have a negative, and I plugged in a 0, minus 2. Well, this negative 0, that's just going to turn into 0, minus 2. And I'm going to keep the 4 on the other side. 0 minus 2 is going to be a negative 2. So 4... we have to know, is 4 less than or equal to a negative 2? This is false. It is not true. We can stop right here because 0, 4 is not going to be in our solution here. If we keep going, 2 times 0 is 0 plus 3. 4 is greater than 3, because 0 plus 3 you would get 3. 4 is greater than or equal to 3. This is true. But this right here being false means that 0, 4 is not a solution. So I can write that in. That point, 0, 4 is not a solution. And the reason being is because of inequality number 2. Okay, it's not a solution to our system because 4 is greater than a negative 2. 4 is greater than 2, but 4 is really greater than a negative 2. Okay, so that's just some practice of, some examples for the practice that you're getting ready to do. So let me know if you have questions. Also, you can let the coaches know if you have questions. We are in this together to help you. Okay, so I want you to now give the practice a try and see what you come up with. Okay, best to you.